A graph can make the formal definition of a limit feel less abstract. First, we will identify the target output, then build an allowed output band around it. Then choose an input window around the approaching value, and finally connect those two regions into the meaning of a limit. To begin the plan, the graph is centered on an input value that x approaches and an output value that the function is supposed to approach. The statement says that as x gets close to a, the function values get close to L. With the target output L, named epsilon, measures how much vertical error is allowed above and below that target. The acceptable function values lie between L minus epsilon and L plus epsilon. Now that the vertical band is fixed, delta measures how close x must stay to a on the horizontal axis. The allowed x values lie between a minus delta and a plus delta, not counting x equal to a itself. With both regions marked, the key requirement is that every allowed input near a must produce a function value inside the epsilon band. In distance language, if the distance from x to a is less than delta, then the distance from f of x to L is less than epsilon. Because the graph must work for any positive epsilon, no matter how small, the matching delta may change but must still exist. That is the Epsilon-Delta definition. The limit of f of x as x approaches a is L, when every demanded closeness to L can be guaranteed by making x close enough to a.